Okay, we're back, and hopefully last night you didn't have any trouble with your binary ionic nomenclature. Today we're going to just work a little bit on some polyatomic ions, and I've given you on page 69 a list of all the ions that I want you to know this year. There might be the odd other one. I haven't included hydroxide and cyanide that we did the other day. Now you'll notice that in your notes I have bolded nitrate, sulfate, carbonate, and phosphate. Those are the ones that the IB use a fair amount. But we're going to use either a lot of these or we're going to come across a lot of these ions in our studies. And so I need you to know all of these. Now, it is a bit of a task for you to know that. I'm going to suggest to you that you use some system to memorize these. Remember, we talk about names and that kind of thing, that you must, you have to memorize names and then you get to know them. It's like me and my students. Now, you can use something very simple like a flashcard, where you can see here I have a flashcard and I've put the polyatomic ion sulfate on one side, the symbology, and then I've put the name on the other. And I really like this system. You can carry these in your pocket, and if you've got a couple of minutes, maybe when you're being driven into school, or if you're on a bus or something like that, you can pull these out and you can go through them. Or maybe you're watching TV and there's a couple minutes of commercials, you can just pull those out and do them very quickly. You don't have any fuss, no muss. Okay, I really like that. Now, there are computer programs and apps that will do flashcards for you. And I have a Quizlet, and I will send that to you by email, where you can challenge yourself to get to know these in sort of a more fun manner. But we have to know these. You have to be able to put these compounds down every time that you're doing balancing equations or answering questions and stuff like that. So I've divided this table into two groups. We've got the 8 ions, okay, over here on the left-hand side, and we've got a much smaller list over here on the right-hand side of the 8 ions, and we'll look at some patterns there in a few minutes. You can read these just as well as I. You have to know the charge, by the way, so you can't just say nitrate, oh, that's NO3. No, it's NO3 minus. Chlorate, ClO3 minus. Sulfate, very common, SO4 2 minus. Carbonates, which you're probably aware, CO3 2 minus. Phosphate, found in bones and teeth and that kind of thing, PO4 3 minus. Now, acetate can be written in a couple of different ways. I like to use CH3COO minus. It helps me figure out that it's actually acetate. C2H3O2 minus can also be used, but I don't know, I just don't have the same recognition. And you'll notice with chromate, dichromate, and permanganate, I've put colors in there. And this is going to be used later on when we're doing some other chemistry to show that a reaction has taken place. For instance, the dichromate might turn from orange to green, or some variation like that. So you want to know the colors of those things. Okay. Now, if we look very closely again, if we look at nitrate as NO3 minus, nitrate is NO2 minus. All right, is that a pattern? Well, let's look at chlorate, ClO3 minus, and chlorite is ClO2 minus. So one less oxygen. We'll try it one more time. Sulfate is SO4 2 minus, sulfite SO3 minus. So it looks like we've got a pattern here. The ite is one less oxygen. Okay, and you can take that one to the bank. Now, you might ask the question: are there carbonites, phosphites, acetites? Not really. These are the three. These are the three that will come up against most often. You may have heard of nitrates in food as preservatives, and sulfites as well. These are used quite a bit in the food industry in order to prevent damage to the food. Now, there are some other ions that we should know, and I've chosen the chlorine family for this. There's our chlorate, okay, that we have up here, ClO3 minus. Chlorite, one less oxygen, chlorite. Now, perchlorate, Now this is a nasty, it's a very explosive anion, ClO4. So per, we can say, is one more oxygen than the 8. Okay, you can take that one to the bank. So you've heard of hydrogen peroxide. Okay, it's H2O2 instead of H2O. So one more oxygen is the per prefix. Okay, and similarly in chlorite here we have hypochlorite. Hypochlorite you may have come across in terms of bleach. Sodium hypochlorite is a bleach, and you probably have that in your house. And that, if you notice, is very close. It's one less oxygen than the ite. Okay, so that is another pattern. So if you look at it, really all you really need to know, if you can remember those rules, are your 8 ions. Okay, and so that's not very many. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a Quizlet for you that you can do, and I think I've got about 21 ions on there, and so it might actually be a little bit more appropriate to do once we've gone a little farther. But anyway, if you can get to know those, then you'll have no trouble whatsoever doing nomenclature. Okay, I'm just going to flip the page here. Now there is one that you've noticed, there is one positive ion, and again it comes up quite a bit, and that is the ammonium ion. And ammonia, you might remember, is NH3. The ammonium ion is NH4+. And nice thing about ammonium compounds is they're all soluble. You can take that one to the bank. And here I've put in hydroxide and cyanide as well. Well, how do we name ionic compounds that contain polyatomic ions? Well, we're going to use exactly the same rules that you learned in order to name binary ionic compounds. And that's with the either the simple or the stock system. For instance, if I have a compound CaCO3, so I have to name this. I have a metal and a non-metal, so I know it's an ionic compound. I'm going to go to my periodic table. I'm going to look at calcium. I'm going to see that there's only one oxidation state for calcium, so it's the simple system. So it would just be calcium carbonate. Okay. Now I could choose something a little bit more elaborate. I could say cobalt and NO3 2 times. So again, I would look at this and say, well, NO3 I know is nitrate. Let's see what I need to know here about cobalt. I go to cobalt element 27 and notice it has 2 valences or 2 oxidation states, so I have to use the stock system. I have to figure out, well, which one is it? Well, I know that nitrate, because I've memorized this, is 1 minus, and there's 2 of them. That must make the cobalt 2 plus. So my name would be cobalt, in a bracket, 2 nitrate. Very simple. Let's do another one here. Let's choose, let's try this one, MnSO4 3 times. So again, we would look at this and say, oh, okay, now what do we got here? I've got 3 sulfates, so I know I have 6 negative charges because I know that sulfate is a 2 minus ion, or at least I would if I've memorized this. So I know I've got 6 negative charges. I look at manganese, I bring my periodic table down again, and I notice that manganese has all kinds of oxidation states, so I have to name it using the stock system, and it would be manganese. Oh, sorry, I'm a little bit out of the camera range here. Manganese 6 sulfate. I have no idea whether that's a common compound or not, but anyway, you should be able to name just about any compound. That's all I want you to do right now. So if you go into the notes, the on-call will have the homework, but you'll see that at the end of your notes, there are all kinds of polyatomic ion nomenclature problems that you can work on. and you can just work your way through that until you've got this system down cold. Okay, thanks very much, and hopefully we'll see you in the next week.